September 1944, Normandy, France. A Sherman tank exploded in a ball of flame as a German anti-tank round punched through its thin armor. 50 yards behind, a massive British tank ground forward through the smoke. The German gunner fired again. The round struck the approaching vehicle squarely on the frontal plate. Metal screamed. Sparks flew. The British tank kept coming. Its tracks chewed through mud and debris. Its hull absorbed punishment that would have gutted any American medium tank. The German crew abandoned their position. The tank that shrugged off their best shot weighed nearly 40 tons and carried armor up to 6 inches thick. British crews called it the Churchill. German soldiers who faced it learned that Britain had built something that simply refused to die. Before you continue, please take a moment to like this video, subscribe to the channel, and share it with someone who appreciates military history. Your support makes content like this possible. The Churchill tank emerged from the most desperate period of British tank design history. Dunkirk had demonstrated the inadequacy of Britain's pre-war armor philosophy. Light cruiser tanks burned easily and provided minimal protection. Infantry tanks moved too slowly and lacked adequate armament. The War Office needed something better. They needed something that could survive modern anti-tank weapons. They needed something that could support infantry through the most horrific combat conditions imaginable. The specifications they drafted in June 1940 reflected both ambition and desperation. Vauxhall Motors received the contract because they were available, not because they were ideal. The company had manufactured cars before the war. They understood mechanical engineering, but they had never designed a tank. The War Office gave them 6 months to create a working prototype, 6 months to design a vehicle that would weigh 40 tons and carry enough armor to stop German anti-tank rounds, 6 months to solve engineering problems that normally required years of development. The timeline was insane. Vauxhall accepted anyway because Britain was losing the war and desperate times eliminated normal procurement procedures. The initial design philosophy prioritized armor protection above everything else. The specification called for heavy frontal armor capable of defeating the German 37mm anti-tank gun that had torn through British tanks in France. Side armor needed to resist machine gun fire and shell fragments. The tank needed to cross trenches wider than anything encountered in the First World War because planners assumed the next German defensive line would resemble the Hindenburg Line. Nobody knew what actual combat would demand. They designed for the last war because they had no other reference point. The hull design that emerged was unlike anything else in service. The Churchill used a rectangular box structure with flat armor plates mounted at minimal angles. This was aerodynamically terrible and metallurgically questionable, but it was simple to manufacture. Vauxhall's production facilities could produce flat plates. They could not easily produce complex curved armor sections. Britain's industrial capacity was stretched beyond breaking point. A tank that required simpler manufacturing processes was worth tactical compromises. The engineers knew their design was crude. They built it anyway because crude tanks were better than no tanks. The suspension system was genuinely innovative, even if it looked archaic. The Churchill mounted 11 small road wheels on each side running on a flat track frame. This gave it exceptional ground contact and distributed weight across a larger surface area than conventional designs. The tank could climb obstacles that stopped other vehicles. It could traverse terrain that would bog down Shermans. The small wheels meant that battle damage to individual wheels had minimal impact on mobility. A Churchill could lose 3 or 4 road wheels and continue fighting. This redundancy was accidental genius. The engine choice was controversial from the beginning. Vauxhall installed a Bedford-flat 12-cylinder engine producing just 350 horsepower. This was grossly inadequate for a 40-ton vehicle. The Churchill's top speed was barely 15 miles per hour on roads and much less cross-country. American tank designers would have rejected the power-to-weight ratio as unacceptable. British designers accepted it because the alternative was no tank at all. They rationalized that infantry support tanks did not need speed. They needed armor and reliability. The Churchill provided both, even if it moved at a walking pace. The initial armament was embarrassingly inadequate. Early production Churchill Mark I tanks carried a 2-pounder gun in the turret and a 3-inch howitzer in the hull. The 2-pounder could penetrate most German tanks in 1941, but it fired solid shot only. There was no high explosive round. The tank could not effectively engage infantry or soft targets. The hull-mounted howitzer was supposed to compensate, but it had limited traverse and was difficult to employ effectively. Tank commanders found themselves commanding vehicles that could barely fight infantry and struggled against newer German armor. The first combat deployment was a catastrophe that nearly killed the Churchill program permanently. The Dieppe raid in August 1942 committed Churchill tanks of the Cavalry Regiment to an amphibious assault against fortified German positions. The operation was a disaster. 29 Churchills landed on the beach. 0 penetrated beyond the sea wall. German anti-tank guns destroyed or disabled every tank. The vehicles that reached the shingle found themselves trapped by concrete obstacles and unable to advance. The crews fought until their ammunition ran out, then surrendered or died. The after-action reports were damning. Critics seized on Dieppe as proof that the Churchill was a failure. They pointed to the trapped tanks. They emphasized the inadequate armament. They noted the mechanical breakdowns. Some called for cancellation of the entire program. The Churchill appeared to be another British tank design disaster in a long line of disasters. Production continued only because Britain had invested too much to simply abandon the project. The tanks kept rolling off production lines while the Army tried to figure out what to do with them. North Africa saved the Churchill from cancellation. The fighting in Tunisia required tanks that could handle mountainous terrain and steep slopes that defeated conventional designs. Churchills of the British First Army discovered their vehicle could climb gradients that Shermans could not attempt. The excessive ground contact and low ground pressure allowed Churchills to traverse mud that bogged down other tanks. The heavy armor that seemed excessive in training proved vital when German 88mm guns engaged at long range. Churchills absorbed punishment and kept fighting. The Battle of Longstop Hill demonstrated what the Churchill could accomplish in the right circumstances. British infantry attacks had stalled against German positions on steep rocky slopes. Conventional tanks could not support the advance because they could not climb the gradient. Churchills ground their way up slopes exceeding 30 degrees. They reached positions where no other tank could go. They provided direct fire support that broke German defensive positions. After Longstop Hill, the critics went quiet. The Churchill had found its purpose. Armament improvements transformed the vehicle from questionable to formidable. The Churchill Mark III mounted a 6-pounder gun that could engage German medium tanks effectively. The Mark IV added a 75mm gun with both armor-piercing and high explosive capability. Now the tank could fight armor and support infantry with the same weapon. The Mark VII increased frontal armor to 152mm and upgraded the suspension. Each successive Mark addressed deficiencies while retaining the core strengths of heavy protection and exceptional mobility over difficult terrain. The Italian campaign became the Churchill's proving ground. The mountainous spine of Italy created terrain that favored the Churchill's climbing ability. German forces established defensive lines across ridges and mountains that dominated the surrounding landscape. The Gothic Line and Gustav Line fortifications seemed impregnable. Conventional armor could not reach the German positions. Churchills could. They climbed fire-swept slopes under direct observation. They absorbed anti-tank fire that would have destroyed lighter vehicles. They reached German bunkers and fired point-blank into firing slits. Monte Cassino demonstrated both the Churchill's capabilities and limitations. The tank could reach positions no other vehicle could access. It could survive in environments that destroyed other armor. But the 6-pounder gun struggled against fortified positions that required heavy-caliber demolition fire. The solution was the Churchill Aviary. The armored vehicle Royal Engineers mounted a 290mm Spigot mortar called a petard that fired a 40-pound high-explosive charge. The weapon had a range of merely 80 yards, but its destructive power was devastating. Aviary Churchills became the primary bunker-busting weapon in the British arsenal. D-Day planning recognized that specialized armor was essential for breaching the Atlantic Wall. Major General Percy Hobart developed a series of modified Churchill variants specifically for the invasion. Churchill Crocodile flamethrower tanks could project burning fuel over 100 yards. Churchill aviary vehicles carried fascines for crossing ditches and small box girder bridges for spanning anti-tank obstacles. Churchill arc bridge layers could position themselves in ditches to create ramps for other vehicles. These specialized Churchills became known collectively as Hobart's funnies. The effectiveness of these specialized variants exceeded expectations. At Gold Beach, Churchill aviaries breached concrete obstacles and cleared paths through minefields under direct fire. Churchill crocodiles suppressed German bunkers with flame attacks that forced defenders to abandon positions. Churchill arc vehicles created crossing points over anti-tank ditches that allowed follow-on forces to advance inland. The specialized Churchills suffered heavy casualties, but they accomplished their missions. Without them, the beach assaults would have stalled at the seawall. The fighting in Normandy revealed both strengths and persistent weaknesses. Churchill armor could defeat most German anti-tank guns at combat ranges. The tank could survive hits that gutted Shermans. But the 75mm gun was marginal against German Tiger and Panther tanks. Churchill crews who encountered German heavy armor learned to avoid direct confrontation. They used their superior climbing ability to flank German positions. They exploited terrain to engage from unexpected angles. They fought smart because they could not fight toe-to-toe with German heavy tanks. The Battle of Villers-Bocage demonstrated the tactical problems British armor faced in Normandy. A single German Tiger tank commanded by Michael Whitman destroyed an entire British armor column in minutes. The engagement emphasized that British tanks, including Churchills, were outgunned by German heavy armor. But Villers-Bocage was an ambush in restricted terrain. In open fighting where British tanks could maneuver and use their numbers, the outcome was different. Churchills absorbed damage that destroyed other tanks and continued fighting. Operation Tractable in August 1944 showed what properly employed Churchills could accomplish. Canadian forces supported by Churchill tanks attacked German positions south of Caen. The Churchills led the advance across open ground under heavy anti-tank fire. Several tanks were hit and disabled. Most shrugged off the impacts and continued advancing. The German defenders reported that British tanks refused to stop despite taking direct hits. The psychological impact of vehicles that kept coming despite punishment was significant. The Churchill Mark VII represented the culmination of the design's development. Frontal armor increased to 152mm. The 75mm gun received improved ammunition. The suspension was strengthened to handle the increased weight. The Mark VII weighed just over 40 tons and was the heaviest British tank to see widespread service. It was also one of the most survivable. Crews trusted in situations where other tanks would be death traps. That trust was earned through combat experience across multiple theaters. The Ardennes Offensive in December 1944 tested British armor under winter conditions. Churchill tanks of the British 6th Guards Tank Brigade moved to support American forces after the German breakthrough. The frozen terrain favored mobility, but the bitter cold created mechanical problems for all vehicles. Churchills proved more reliable than expected in extreme cold. Their simple mechanical systems were easier to maintain than more sophisticated American designs. They kept running when other vehicles froze solid. The Rhine crossing operations demonstrated the Churchill aviaries' continued value. German defenses along the Rhine included extensive fortifications and obstacles. Churchill aviaries carrying fascines and bridge sections led the assault crossings. They filled anti-tank ditches and cleared obstacles under direct fire. The 290mm petard remained the most effective weapon for demolishing concrete fortifications at close range. Aviary Churchills continued performing missions for which no other vehicle was suitable. The final campaign across Germany vindicated the Churchills' design philosophy. British armored divisions advanced through territory that alternated between open plains and dense urban areas. Churchills proved invaluable in urban fighting where their heavy armor provided protection against German anti-tank weapons fired from buildings at point-blank range. The slow speed that had been criticized as a weakness became an advantage in cities where rapid movement was impossible anyway. The Churchill was built for grinding attritional warfare, and the final campaign was exactly that. Reliability statistics reveal an important truth about the Churchill. Early Marks suffered mechanical problems that justified their poor reputation. Engines failed. Transmissions broke. Tracks threw regularly. But later Marks proved surprisingly reliable for such a heavy vehicle. Churchill Mark 7 tanks achieved operational readiness rates comparable to or better than American Sherman tanks. The simple mechanical layout that seemed crude actually improved field maintainability. Crews could repair damage that would require depot-level maintenance on more sophisticated vehicles. Production numbers exceeded 11,000 vehicles across all variants by war's end. This made the Churchill one of Britain's most numerous tank types despite its troubled beginning. Vauxhall and other manufacturers produced Churchills continuously from 1941 through 1945. The manufacturing process improved dramatically as workers gained experience. Initial vehicles required extensive hand fitting and adjustment. Later vehicles rolled off production lines with minimal issues. British industry had learned to mass-produce heavy armor. Crew opinions of the Churchill evolved dramatically over the war. Early crews hated the vehicle. The cramped interior and inadequate armament made it unpopular. The mechanical problems reinforced negative perceptions. But crews who fought in later Mark Churchills developed genuine affection for the vehicle. They trusted its armor. They valued its reliability. They appreciated that it brought them home alive from engagements that would have killed them in lighter tanks. Veteran crews requested Churchill assignment because they knew it gave them the best chance of survival. German military intelligence assessed the Churchill as a formidable opponent despite its limitations. Captured German documents note the vehicle's exceptional armor protection and ability to operate on terrain that defeated other tanks. German anti-tank crews were instructed to aim for track and suspension components because frontal armor was often too thick to penetrate. The intelligence report specifically warned that the Churchill could climb slopes and cross obstacles that seemed impassable. German defensive planning had to account for Churchill capabilities. The Churchill's shortcomings remained significant despite improvements. The tank was slow. The 75mm gun was barely adequate against late-war German armor. The interior was cramped compared to American designs. The visibility from inside the tank was poor. These were real problems that affected combat effectiveness. But every tank design involves compromises. The Churchill sacrificed speed and firepower for armor protection and terrain mobility. In the combat environment, where it actually fought, these were acceptable trade-offs. Post-war evaluation confirmed the Churchill's significance. British Army analysts concluded that the Churchill was the most survivable British tank of the war. Casualty statistics showed that Churchill crews had higher survival rates than crews of other British tank types. The heavy armor justified the weight and complexity. The slow speed was less critical than critics had claimed. The tank had been designed for close infantry support and breakthrough operations. In those roles, it performed exactly as required. The Churchill remained in British service long after the war ended. The Irish Army operated Churchills into the 1960s. The Royal Jordanian Army used them even longer. The vehicle's robust construction and simple mechanics allowed extended service life. Later variants received upgraded engines and improved fire control systems. The basic design proved adaptable enough to remain relevant decades after its initial deployment. Few tank designs achieve such longevity. Museums preserve multiple Churchill variants today. The Tank Museum at Bovington displays representative examples of most marks, including specialized variants. The Imperial War Museum collection includes both standard gun tanks and aviary vehicles. Historical societies maintain running examples that demonstrate the vehicle's capabilities. The sight of a Churchill climbing a steep slope still impresses observers. The engineering solutions that seemed crude in 1941 appear elegant in retrospect. The specialized variants deserve particular recognition. The Churchill Aviary remained a standard British combat engineering vehicle for decades after the war. The Crocodile flamethrower influenced subsequent flame tank development. The arc bridge layer established concepts still used in modern armored engineering equipment. These variants extended the basic Churchill design into roles never envisioned during initial development. The adaptability of the chassis demonstrated sound fundamental engineering. Comparative analysis with contemporary tanks illuminates the Churchill's unique characteristics. The German Tiger tank had superior firepower and comparable armor, but was mechanically unreliable and difficult to produce. The Soviet T-34 had excellent mobility and adequate firepower, but lighter armor. The American Sherman was faster and more reliable, but poorly protected. The Churchill occupied a unique position, emphasizing survivability above all else. No other nation built anything quite like it. The human cost of tank warfare justifies the Churchill's design priorities. Tank crews face horrific casualties throughout the war. Vehicles that caught fire burned their crews alive. Penetrating hits filled crew compartments with molten metal and explosive fragments. The difference between thick armor and thin armor was the difference between going home and dying screaming. Churchill crews understood this viscerally. They accepted slow speed and mediocre firepower because the alternative was burning to death in a vehicle with inadequate protection. Captain Robert Boscawen commanded Churchill tanks in Normandy and later wrote about his experiences. He described the sensation of German anti-tank rounds striking his tank and failing to penetrate. The noise was terrifying. The impact shook the entire vehicle, but the crew survived. Boscawen credited the Churchill's armor with saving his life multiple times. He noted that nearby Sherman tanks hit in the same engagements burned immediately. The Churchill absorbed punishment that would have been fatal in any other British tank. The legacy of the Churchill extends beyond its combat record. The vehicle represented a fundamental shift in British tank design philosophy toward prioritizing crew survivability. Post-war British tanks continued emphasizing heavy armor protection even when this compromised other characteristics. The Centurion tank that entered service in 1945 carried the lessons learned from Churchill combat experience. British armor doctrine evolved to recognize that keeping experienced crews alive was more important than marginal improvements in speed or firepower. September 1944, a Churchill tank ground through Norman hedgerows, absorbing hits that would have destroyed lighter vehicles. German anti-tank rounds struck its massive frontal plate and ricocheted into the sky. The crew inside felt each impact, but they kept fighting because the armor held. They advanced because the tank refused to die. British engineering had created something that looked ungainly and outdated. It was slow. It was crude. It was built like a mobile fortress because that was exactly what infantry needed. The Churchill was not the fastest tank. It was not the most powerful tank. It was a tank that brought its crew home alive. Sometimes that was all that mattered.